Hi everybody! In this video, I'm going to go through our lesson 4.6 on perfect square trinomials and differences of squares. And I want to start off with a super important note. When factoring a polynomial, always check for a GCF, or a greatest common factor, first. So scan your polynomial. If it has a greatest common factor, then factor that out. And then either you're done or you're left over with some polynomial that can then be factored further. And if you don't have a GCF, then we can try other methods. So let's talk about perfect square trinomials, and then we will talk about differences of squares. These are two kind of different forms that are kind of unique forms to look out for and know kind of how they work. So a perfect square trinomial is three terms that comes from some binomial a plus b squared. We also could have a minus b squared, right? Two terms, one separated by a plus, one separated by a minus. If you take that binomial and you square it, it's going to produce some trinomial, and that trinomial is then a perfect square. So what do these forms look like? A plus b squared, if you expand that out, you actually will get a squared plus 2ab plus b squared. And a minus b squared, that's really the same thing as a squared plus, not plus because it's subtraction, it would be minus 2ab minus b squared plus b squared. I always do that. I always want to flip the second value. And I was going to show a diagram and show you why this one is this way. So think about if we were going to actually multiply a minus b squared. So I'm going to multiply here a minus b times a minus b. A times a is a squared. A times negative b is negative ab. Negative b times a is negative ab. And negative b times negative b gives me positive b squared. So altogether, I have a squared minus ab minus ab plus b squared. And these two negative ab's, those combine. I have two of them. So I have a squared minus 2ab plus b squared. So these are our two general forms for perfect square trinomials. I usually check for them by kind of looking at the first and last terms and then seeing if the middle terms make sense. And then I can go ahead and factor that trinomial to have the form of just a binomial squared. All right, let's now talk about differences of squares. So what is a difference? Differences of two squares. And I will sometimes abbreviate this, and you will sometimes see this abbreviated as DOTS, difference of two squares. And it's exactly like it sounds. It's a difference. So we have some term being subtracted from another, and the two terms are squares. So we have a squared minus b squared. So the keys here are that it must be two terms. It must be subtraction. And both terms, this is the most important part. I mean, they're all important, but both terms must be perfect squares. So if you have two terms, if they're being subtracted, if both terms are perfect squares, then we can factor it to be two different binomials. And it's really just A plus B times A minus B. And I'm going to write this a little bit better. So it's A plus B times A minus B. So notice when you factor this difference of two squares, one of them will have a plus sign and one of the binomial factors will have a minus sign. And then it's really just the square root of A and the square root of B. All right. Let's look at some examples. Example 1. X squared plus 16. Nope, it's supposed to be minus, my bad. X squared minus 16x plus 64 is a perfect square trinomial. Factor completely. So in this example, they're actually telling us how to factor, which is so nice. It's a perfect square trinomial. So that's great. I don't have to check for a GCF or anything. And hopefully we notice there is none for this. So x squared minus 16x plus 64 is one of the perfect square trinomials. And that means it came to us by some polynomial or binomial more specifically, with two terms being either added or subtracted, and then that binomial is squared. So the way I look at this, we know that this general formula is going to be a squared, and then we're going to have 2ab as our middle term, and then we're going to have plus b squared. And in this example here, we notice that it's a squared minus 2ab plus b squared. So what is a and what is b? Well, notice here that a squared is x squared. So taking the square root of x squared, we get x. So a is x, and b squared is 64 in this polynomial or in this trinomial. So taking the square root of 64, the square root of 64 is 8. So that's our b. So why did I find a and b? Because I know if I have some perfect square trinomial of the form a squared minus 2ab plus b squared, that's really the same thing as a minus b squared. So we know a and we know b. So that means then that this polynomial is really the same thing as a minus b, or x minus 8 squared. And if we check our work on this, x minus 8 squared is really the same thing as multiplying x minus 8 times x minus 8. And if we multiply that out, x times x will give me x squared. Negative 8 times x. Oh, I realized I did insides first. My bad. FO would be to multiply x times negative 8. So negative 8x, and then negative 8 times x is negative 8x, and then negative 8 times negative 8 is positive 64. So altogether, this gives us x squared minus 16x plus 64. Because I had two of these minus 8x's, those combine to give us negative 16x. So this is the correct factoring for this polynomial. I found the square root of a squared, so took the square root of the first term, that was a, took the square root of the second term, that was b. I recognized that these two terms were being subtracted. Now this only works because it was a perfect square, and they told us that. So sometimes you're not going to know that it's a perfect square, and you're going to have to figure that out. So example 2, we're going to factor 9n cubed, squared, sorry, plus 30n plus 25 completely. All right. So looking at this here, always check for a GCF first. Is there a greatest common factor in this polynomial? Looking at our terms, one of our terms is a constant. It doesn't have any variables, so there's not a common n I can pull out. And factors of 9 are 1 and 3 and 9. And factors of 25 are only 1 and 5 and 25. So there's no GCF here. And I noticed that this has 3 terms, right? This is a trinomial. So I might see if this is a perfect square. So is this some a squared plus, because there's a plus sign, 2ab plus b squared? Let's find out by simply testing, right? We can see what a is and what b is, and then figure out if 2ab is the same thing as 30n. So a squared is 9n. So taking the square root of 9n squared, we can figure out just a, right? Just a is 3n. And then b squared is 25, which tells me then that 5 is b. So I know a is 3n and 5 is b. So what is 2ab? Well, 2 times a is 2 times 3n times b, which is 5. So I'm going to multiply 2 times 3n times 5, and really here's just a bunch of numbers to multiply to n. So 2ab in this case is 2 times 3, which is 6, times 5, which is 30n. So 2ab here is equal to 30n, which means this is a perfect square trinomial, and therefore I can factor it. We got the same piece as 30n, and that was 2ab. So what can I do? I know that this is a positive in here, which really that's that first term, or that first plus or minus sign, tells you whether your general factored form is going to be a plus b or a minus b. And in this case, we have a plus, so it would be a plus b squared. And I found a to be 3n. I was looking at the first part. 3n and b is 5. So 3n plus 5 squared should give us 9n squared plus 30n plus 25. And let's see if it actually does. So I'm going to multiply 3n plus 5 times 3n plus 5. And I'm just going to use the FOIL method. So first we will multiply 3n times 3n to give us 9n squared. And then we will multiply 3n times 5 to give us 15n. And then we will multiply 5 times 3n to give us 15n. And then we will multiply 5 times 5 to give us 25. Oops. So all together, this does multiply out to 9n squared plus 30n, because 15 plus 15 gives us 30n plus 25. So we did factor this perfect square trinomial completely. All right. Example 3. We are going to factor completely y squared minus 49. So looking at this example here, I notice there is no GCF. And this couldn't be a perfect square trinomial. There's not 3 terms. So is this a difference of 2 squares? Well, I do see the subtraction sign. Y squared is a perfect square, and 49 is also a perfect square. So this is a perfect square, which then means it's going to factor into the form of a plus b times a minus b, right? The same set of parentheses, one with a plus, one with a minus. So let's figure out what's a and what's b. So I'm going to start by taking the square root of y squared, which is y. That'll go in the first place of both of my parentheses, and then I will take the square root of 49. And the square root of 49 is 7. So that will go in the second place of both of my parentheses. So this is y plus 9 times y minus 7. And if you expand that out, you'll notice the middle 2 terms would cancel each other. So you'd be left with just y squared minus 49. All right, this is going to be our last example. We are going to factor completely (18x to the 6th minus 2). So looking at this example, is there a GCF? I do see one. 2 and 18 x to the 6th power have a GCF in common. So I could, write the terms out. Really, our numbers that we're looking at are 18 and 2, and the GCF of 18 and 2 is just 2. So I can divide both of these terms by 2. And when I do that, I'm able to factor the 2 out of the outside of a set of parentheses. And what we're left over with, 18 divided by 2 gives me 9x to the 6th power. And then 2 divided by 2 is 1. So 9x to the 6th minus, carrying down the minus sign, minus 1. Now, looking at what we have left, I'm going to write this kind of over here. I have 2 times 9x to the 6th minus 1. There's no GCF left, but notice this 9x to the 6th minus 1. We actually have 2 terms, and 9x to the 6th, believe it or not, is a perfect square, and 1 also is a perfect square. So I have a difference of 2 squares here now. And I want you to make a note. Any even exponent is a perfect square. It can divide by 2. So let's factor this expression further, right? Now we know it's a difference of 2 squares. It's still going to have this 2 out in front of it. So I'm going to have 2 times this new set of parentheses, one with a plus and one with a minus. Oops. And then I need, my A and my B. So I'm going to start by taking the square root of this 9x to the 6th power. So square root of 9x to the 6th. Well, the square root of 9 is 3. And then the square root of x to the 6th power is x to the 3rd power. You simply take that exponent and divide it by 2. So 6 underneath the radical is like 3 x's outside of the radical. And that then 3x cubed will go in the first position in both of these binomials. And then I also will take the square root of b. And the square root of 1 is just 1. So this factors to 2 times 3x cubed plus 1 times 3x cubed minus 1. And looking at this, this cannot expand any further because this last binomial here is no longer a difference of two squares. 3x cubed is not a perfect square. While it is a difference of two terms, both of them are not perfect squares. So our final answer I would write out as 2 times 3x cubed plus 1 times 3x cubed minus 1. Please let me know what questions you have on this lesson. I know that these kind of take a little bit of practice, and so you can always send me a screenshot of a problem that you're stuck on, and we can chat about it.